Okay, today we're going to be talking, or continuing to talk about quadratic functions. But rather than having you solve a quadratic function using the quadratic formula, well, we'll be using the quadratic formula today, but rather than solving one of these to graph using Desmos, we're going to talk about how we would graph the quadratic function manually.
Oh no.
So we're going to have kind of a step-by-step process that we're going to go through. So this is our standard form, right, for a quadratic equation. So we're going to start by trying to find the vertex. So there's kind of like a formula, if you will. So for the vertex, it's going to equal, for our point, the first point, the x value, is going to be negative b over 2a. So to get the vertex, you have it in this form, and then you do this. Then once you get this, you plug that into your formula, and that'll give you your y value for the vertex. So let's look at an example. So y equals 2x squared. Whoa, that's not very good too. Okay, let's see. 2x squared minus 3x plus 1. Okay, so what does a equal?
Can you guys see that?
2.
Okay.
2, yes. Okay, what does b equal?
Sorry, I'm writing that.
Ask one of the other ones.
-3, yeah.
Negative 3.
Wait, is it -3 because negative and negative makes positive?
What, we're not going to that formula. Right now, we're just identifying A, B, and C.
Okay, what does c equal?
Is that 1 or 2? I can't think. Is that a 1?
That's a 1, yeah.
Okay, so it's 1.
Okay, so our vertex equals, so what's negative b?
3.
Negative b is 3. Okay, and then what is 2 times a? 4. Yeah, it's 4. Okay, so now
So 3/4 is the vertex.
no, well 3/4 is the x value
Oh.
of the vertex, right? Okay, so for the y value, what would we do? I said it just a few minutes ago. We would plug it into this equation right here, right? So we have y equals 2 times 3/4 squared minus 3 times 3/4 plus 1 equals. Okay, so what is 3/4 squared?
3 divided by 4 squared.
Or.
Let's do this in
square the
fraction. Let's keep it as a fraction.
4.
What would it be squared as a fraction?
The 3 and 3, so 6, 6/8.
Oh wait, no. 1 over 3 over 1. 3 over 2.
What?
Okay, what does it mean
What
to
does it mean
square
to what does it
3/4?
mean to square 3/4?
3/4 times 3/4.
Yep.
Okay, what would you get
would you
then?
get?
Yeah,
So you would
3/4.
cross multiply. So 3 times
You
what?
get 6 or 1
Or just
1 and
go
1
across.
You get 1 and 1 half. Or wait.
What is
9.
Oh,
it?
that's multiplying by
Okay,
2.
set it over to the side.
9.
Okay,
3/4
3/4.
times 3/4.
4 times
Okay.
4 is 64. So it would be 964.
You get 0.56.
Okay, we want to keep it as a fraction.
So that would be
964.
like 1.
So what is
What are we
3/4
doing?
times 3/4?
That'd
So
be
if we have
56 100ths.
Isn't it 9? Wait, 16 over 9?
You mean 9 over 16?
Yeah.
That's what I said, but I said it wrong because I said 4 times 4 is 64, which is wrong.
Yes, that is wrong.
had the right answer, but it was wrong.
Okay, so this would be minus 9/4, right? Does everyone understand that part?
Yeah. Yeah.
Where you need to go back and review your fractions, that's why we pull them in every once in a while.
Yeah. We might need to do them again.
Okay,
That's-
so okay, y equals. So this is going to be what? It's going to be 18/16, right?
Can you reduce 18/16?
Yeah, we can. Minus 9/4 plus 1. So what does this reduce to?
Or reduced to.
What number goes into both 18 and 16?
2 and 4.
No, 4
No,
does
4
not.
You liar, you got
So what number goes into it? If I reduce it by that, what do I get?
I think you get 9/8, don't you?
Yes.
Okay. So this equals.
If the decimals are going forever, we could keep it in decimal form.
Okay.
Yeah.
What
But
what
right
is
now
this?
We're doing this fraction.
What is
Shut
this
your
in
trap.
terms of eighths? So if we multiply this by 2 and that by 2, what do we get?
18/8.
Yeah. Does anyone understand where the 8/8 came from?
Check your sign there. So what's the answer to that? Come on, somebody do it quickly.
9 minus
So that's gonna
18.
go the way the girls can't see.
17/8.
Wouldn't it just go easier if you do decimals?
No,
I mean, oh wait, no, 9 minus 18. Oh, it's a negative.
It is a
Only
negative.
1.
Negative what?
1.
No, it's negative.
Gosh dang it.
You can do it.
9 minus
Parentheses?
18.
yes,
Plus.
it's -1.
Yeah, it is -1.
Over what?
Yeah.
-1 over
Well, yeah,
8.
it's -1/8. Yeah.
Yeah.
Okay, I thought they were.
Yeah, they were just doing.
Yeah, so it's negative. So this is -1/8. So that's what our vertex is.
Now, if you did not understand that process,
Ask
with
questions.
fractions, you need to go back and review some of your fractions. You need to know how to do that.
That was complicated, but it made sense.
Yeah.
Okay. So it's very important for you to think about each step. What does it mean to multiply fractions? Because that's really what squaring fractions is multiplying the same fraction by itself. Okay, and we went through that earlier in chapter 8, I believe, or earlier in 9, I don't know where it was. It was somewhere. I think it was chapter 8.
So for our process that we're doing to solve these and graph them manually, step 1, I would recommend you always find the vertex. So that's gonna, for the x value, that's gonna be that -b/2a, and then you're gonna plug it in and get your y value for the vertex.
I have a question for the class. Does anybody recognize -b/2a? Have they seen that before?
Negative b. Oh, yeah,
Where?
the vertex.
Oh, I just said it. Where else do you find -b and 2a?
I'm not sure.
Think about the formulas that we have with quadratics.
Is this just the quadratic formula?
It's part of the quadratic formula.
And then,
Get rid of your square root part of your quadratic formula and you have -b/2a.
Oh, you do?
If you get rid of the plus or minus the square root, you have -b/2a. So it's everything but the square root of your quadratic formula. It's the same thing, except for you get rid of the square root. The square root, that thing you add is actually adding and subtracting from your x value of the vertex to find your two x-axis because it's symmetrical. Yes,
When was the quadratic formula like created?
I have no idea.
In the beginning.
That's all.
That probably was. That's true, God probably knew it, but we as a people didn't discover it until
Do you think
later.
it's more modern or like 1700s?
Oh, I see, it's probably,
18.
I believe it's probably earlier than that, in the
Really?
1500s, somewhere in there, yeah.
Well, 15 they didn't have, that was the dark ages because they didn't write anything down, so I would say 16, 17.
Okay, maybe 16, 17, yeah. Okay, let's go on
Who's
to the
doing
next
this
step.
for fun in the 1700s? Who's like, I'm gonna sit down and I'm just gonna throw a bunch of numbers
Now
and
you have to
letters together
remember,
until
you have
it
to
works.
remember, they didn't have computers, they didn't have televisions, they didn't have cars, they didn't have shopping malls. They had a lot more time on their hands. So they started looking into things and they were very interested in learning. They wanted to learn more and discover more. That was a really big thing.
Because they were rich.
Yeah, because they were bored.
Well, if they
They
weren't
aren't
rich, they
rich.
couldn't, if they weren't rich, then they couldn't buy food
And then they were working
to,
it back.
and then they were working, well, not in a
Okay,
factory.
let's go back to this.
But yeah, so,
Mr. Golf taught us that.
you don't have enough time on your hands if you don't have enough food. So
Yeah.
if you have an excess of food, then you have enough time to,
Work on the arts.
yeah.
Okay, go on.
Okay, so the next step in graphing is to find the y-intercept. So the y-intercept, effectively, if we have y equals ax squared plus bx plus c, the y-intercept is where x equals 0, right? So if x equals 0, that means this cancels out, so y equals c. So basically the y-intercept is always just your c value for the y.
0, comma C.
Yes, so the coordinate of the y-intercept is going to be 0, comma, well, yeah, c, I guess. Or you could, in our case, the y-intercept is 0, 1. Because we're working with this same equation, and for it, the c value was 1. In this case, for our example. Any questions on that?
That's the hard one to do.
So it just becomes the C value basically?
Yep.
To find, okay.
Yeah, so that one's really easy, yeah. There's no negative b over 2a or anything, yeah.
So C we just do 1 again.
But the coordinate for the y-intercept is an x value of 0 and then a y value of 1. Okay, now we move into phase step 3.
Trace.
Trace.
I should be a comedian.
Okay, so now we want to find this is step 3, I believe. So find x intercept. So for that, we just use the quadratic formula. So we have negative b plus minus the square root of b squared minus 4ac over 2a, which equals, so negative b is going to be what? Yeah, it's going to be 3 plus minus the square root of, what's b squared?
Move back.
Oh.
Oh.
So b is negative 3.
Yeah.
So if b is negative 3, what's negative 3 squared?
Wait, sorry, say that again?
So what is negative 3 squared?
Negative 3 squared would be positive 9.
Positive 9, yeah, positive 9.
B squared, no matter what you have, will always be positive in this.
Okay, and what is a?
2.
A is 2, so it's going to be 2. And then c is 1, so that's easy enough. All over 2 times a, what's 2 times a?
4.
4, yep.
Remember, we already saw the 3 and the 4 before.
Wouldn't it be -3? Or oh wait, no, wait. Yeah, it's -b, isn't it? So that would make the 3.
No,
that
because it
first
was
three.
another negative, because -3 was already.
No, it wasn't -3, was it?
For
For-
B.
For
the
B?
first B.
B was -3.
Oh, b was -3.
So
Yeah.
the opposite of -3.
Oh, I didn't have it written down as -3. I just had it written down as 3.
Right.
So it
the
was-
B is -3. Yeah.
B is -3. Okay.
So positive, that's going to be, or if we have a negative in front of it, it's going to be
it's
as
gonna
positive.
be positive.
Okay, so here we have 4 times 2 times 1. What's that?
8.
Yes, and it's negative, right?
Yep.
Okay, so we have 9 minus 8, which is also known as what? 1. Okay, so effectively, we have 2 different answers here. We have 3 plus, the square root of 1 is 1, right? So 3 plus 1 over 4, so that equals 1. Everyone see that?
Mm-hmm.
And then we have 3 minus 1 over 4, which equals 2 over 4, which equals what? 1/2, yeah. Okay, so now at this point, since we have our x-intercepts, as well as our vertex and y-intercept, we can actually go ahead and work on graphing this. And I will try to make it so Brielle and Ava can see it. Okay.
And summarize all those points.
That's a good idea. Yeah, I will put them up here first so we can see what's going on.
So that was all one question.
Yes, these are pretty involved.
Wow.
Okay, so, okay.
Is this step quad or wait 5? Quattro. No, this is step 4.
So the vertex, so we have,
Quattro 4.
so vertex
Quattro is 4.
equals, what was it, 3/4?
-y.
Okay.
Y-intercept.
So effectively we have 4 points that we can graph. Does everyone see that? So over here, we got okay.
A question for you. Why did he label his graph like that?
This is the 1/2 and then 3/4.
He wanted to expand so you could see it better. If you just wrote 1 as the first spot, all that would be within that little area between the first ones. And that makes it very small. You can't see it very well. So when you have numbers like this, your biggest number is 1 and 1 on both the intercepts. And so all the rest of them are fractional, so break them into fractional spots.
Okay, so for the first one, the vertex, we have an x value of 3/4, so that's going to be right here, correct? Let me see that. And then it's going to be a y value of -1/8. So effectively, it's going to be right around here, I believe. Everyone see that?
No, is it -1/8, isn't that the line down below? You're going up by 1/8.
No, this is 1/4. I'm doing 1/4 at a time, right?
Oh, you're right, I'm
Yeah.
sorry.
So this is -1/4. So that's, yeah, I think that's right.
That is,
Okay, so then where is our y-intercept?
At 0, 1.
So that's gonna be way up here, right?
Mm-hmm.
Okay, and then our first x-intercept?
At 1, 0.
Yeah.
So,
So what's the x value?
1.
Okay, and then where is our second x-intercept? Yeah. So we can we know this is our vertex, right?
Mm-hmm.
So we have a parabola that's coming up like this, and then coming up like so. And then they should be, and then it should be symmetrical. So you can actually, so if this is 1, 2, 3, up 1, 2, 3, 4. So we could go 1, 2, 3. Yeah, around it. We should have these 2 points symmetrical. Does that make sense? So yeah, so by finding these 4 values, you can go ahead and graph it manually. Okay, any questions?
Oh wait. Never mind. I was just thinking if you just put in the first question, then it would show you, like on Desmos, would it give you that?
it would give all that to you, yes.
Oh.
Or it'd give you that, then you'd have to go find the actual points on the graph. But this is when you're manually graphing it, so I want you to understand you can manually graph it because most people did not have graphing calculators that did it for them. So you used to have to do it by hand. And so sometimes it's good to understand why it's doing that and how to do it.
All right, well go ahead and take your break and we'll come back and do a problem on the board.
Finally.